Hi everyone, my name is Gabe, and today I'm going to be giving you a brief tutorial on how to discover and access and analyze data using Brick. To do this, I'm going to be bringing together a few open source technologies, TimescaleDB, which is an extension for Postgres that manages time series data, Brick schema, which is a Python package that makes it easier to manage, compile, and query Brick models, and Jupyter, which is a web-based development environment for data science and Python. So I've gathered a collection of resources. There's going to be in a repository, so you can follow along on your own machine. And the link to that repository will be. Okay, so to get started, I'm going to take a look at what's inside this repository. There's a few things of note. The first thing that we want to do is start up the Docker containers. So I've put a script here that will do that for you. This will run Jupyter and it will run TimescaleDB for you. This ran really quick because I already have those images downloaded and cached, but this might take a little bit longer on your machine. But if you run Docker PS, you should be able to verify that TimescaleDB is running on 5432 and Jupyter is running on at least port 8888. Okay. The next thing I want to do is start the data ingestion process, because that can take a little bit of time. Luckily, there's a script to do that as well. We'll just run the setup script. And while that's running, I'll show you what that is doing. So we have here a sort of bog standard database schema for time series data. It's got three columns. It's got the timestamp column, it's got the value column, which is going to store the actual data values, and it's got this UUID column, which is going to be the pointer between the Brick model and the time series data. So for a particular sensor or data source in Brick, in the Brick model, that will have a UUID associated with it, and we will use that UUID to fetch the data out of the database. These last two lines are required. This one just creates an index so that queries are a little faster, and this last one is how we create a time series table in TimescaleDB. Okay, so we have the Jupyter Notebook running, so I'm going to go to my browser. If this, the default password is stored inside the Docker startup script, it's I think my password in no spaces, all lowercase by default, so feel free to change that. Everything should still work. Okay, so here what we're looking at is the building2.ttl file. This is the Brick model representing our building and its data sources. You can see we've got some air handling units here. They have some points associated with them. If we scroll down in the file, we can find the descriptions of these points. This one here is an outside air temperature sensor. It's units or degrees Fahrenheit. And here is the UUID that we mentioned before. So the time series property has this time series ID, value embedded in it, and the value of that is this UUID, which we will extract UUIDs out for the sensors and data sources we care about using a query against the Brick model, and then we will take those UUIDs and give them to the time series database to get the actual data. So before we do that, there's one thing that we need to do, which is compile the Brick model. Compiling the Brick model will add a bunch of implied information that our queries can use, which is going to be helpful because it will it'll simplify some of the queries. It'll make certain connections that are implied explicit so that the queries can leverage them. And it does take about a minute to do, but it's something you only have to do when the Brick model changes. So before we do that, let's really quickly install the requirements. These are just the dependencies that our Python code is going to depend on. While it's installing, we'll take a look at the compile script. I just wrote this in a quick minute here. What it's going to do is take a file name off of the command line when we run it. It's going to create a graph object. A graph is the unit of management for a Brick model. It contains all the triples describing the data sources and the equipment and everything for a particular site. when we use brick schema, we can give it this flag here, load brick nightly, and it will download the latest version of brick and put that into your graph so that your tools can use it. And this next line, load file, will just pull the building2.ttl file into the graph as well. To compile, we just run this one command, building.expand. That'll take, I think, about a minute. And then lastly, it'll write it out to a new file called compiled building2. So I've already done this. You don't have to wait for me to run that code. You can see that it's got some stuff in here from the brick ontology that wasn't in our brick model. It's going to be much, much larger, but generally it's not something that we have to look at explicitly. Okay, so I think we are in the process of getting that data still loaded in, but we can still move forward. I'm going to create a new notebook. And inside this notebook, I'm going to run just a few import statements. We're going to get the pandas library. We're going to import the brick schema library. And I think we want to do this little command, which will put the plots inside the actual document. And then psychopg2 is the Postgres client. Okay. So first, let's pull in our brick model again into a graph object and start running some queries and figure out what kind of data we can access. So I'm going to call my object G. I'm going to load the compiled building2.ttl file. And that will give me my graph object. So one thing we can do, if I do this serve here, what this will do is this will start a web server and I can start to query my brick model interactively. So let's go and run that and give me this little link. Oh, maybe it's not complaining. Well, that is okay. We don't need to do the interactive version. This works better not in a Jupyter notebook. Okay. So let's write a query here. And then for row in g.query, print row. Okay. So I know from the brick model, well, let's just write just a basic discovery query. Select distinct sensor type where sensor is a sensor type and sensor type anything that is a sensor, get us the distinct list of those classes. So it looks like this model only has flow sensors and temperature sensors, which is fine. That is, there we go. Put a little star in there, get a little bit more. We can see we have discharge airflow sensors, supply airflow sensors, supply air temperature sensors, and so on. So we can now also write a query to see what kinds of sensors exist on the air handling units. I can also just look at the model directly. So this air handling unit has mixed air temperature, outside air temperature, return, and supply. Let's take a look at the supply air temperature and the supply air temperature set point. So what I'm going to do in my query, I'm going to select the air handling unit, the supply air temperature sensor, and the set point. And when we write the brick queries, we write out the variables that we want to get out, and then we write down the constraints that show how the variables of those types are related. So AHU is any entity that's an air handling unit. It has points. So I want the SAT and SP that are related to this air handling unit. SAT is a brick supply air temperature sensor, and SP is a brick supply air temperature set point. If I run that, it's a little hard to tell here, but I get my error handling unit, I get the supplier temperature sensor, and the supplier temperature set point. And these are all the URIs of the actual entities in the brick model. However, we don't yet have the UUIDs that tell us how to get the data out. So let's add the SAT UUID and the SP UUID variables to our query. And the way that we're going to retrieve those is I'll put a semicolon there. Brick time series has time series ID. Set UUID. Put a period. And then this one, very similar construction. Okay. All right, there we go. So now, there's a few more of these now, but you can see, let's look at a particular one of these. We've got the name of the air handling unit, the name of the supplier temperature sensor, the name of the supplier temperature set point, and then two UUIDs. They're positionally related, so the first one relates to the supplier temperature sensor, the second one relates to the supplier temperature set point. And so what I'm going to do is I'm going to write a little method that's going to turn these query results into a data frame, just so that's a little bit easier to manage. Sparkle to df. I'm going to take in a graph and a query. It's going to run the query on the graph. Then we're going to get a pd.dataframe.from records. Let's just see what that gives us. Sparkle to df, run our graph G, and that query Q. Need to make this a list. All right, so there's all of those results. That's still a little messy, and there's some duplicate values in there. And so what we're going to do, I think it is called apply map. Then df drop duplicates. So what this first line is going to do is going to convert everything to a string, just so we don't have to worry about different data types. They're all going to be strings anyway, essentially. And then that's when we'll get rid of any duplicate rows. And there we go, a lot better. So there are 4 air handling units, 1, 2, 3, 5, and 1. They've got these sensors, and they've got those UUIDs. Okay, so now we can write the code to actually start getting data out of the database. The way we're going to do this is we're going to use the CyclePG library to open a connection to the Postgres database. We're going to write a SQL query where it's going to take some UUIDs that we want the data for, and it's going to pull those out and give us those data, and then we'll massage that into a data frame so it's a little bit easier to visualize and manipulate. Okay, so we're going to start with, this is our data frame here. We'll call it MD for metadata. MD.head. So let's say the UUIDs that we want are we want this first UUID and this second UUID. Then what we're going to do is we're going to open up that connection to that Postgres database. So psychopg2.connect, localhost, no, it's on TimescaleDB, 5432, Postgres, Remember to change this password if you changed that in the configuration when you started your database up. And so now we're going to take advantage of a really helpful pandas functionality, which will take the results of a SQL query and put it into a data frame for us. So our data frame is going to be pd read SQL. Actually, let me open a new thing here. So read SQL takes in the SQL string. So let's first do that. So the query, we're going to want the time, the value, and the UUID from data where UUID equals any. So this construction here, UUID equals any %s. That %s will be substituted with the array of UUIDs that we want data for, and this construction will make sure that we get data for any row that has a UUID that's inside that list. This is a little bit more readable and flexible than having a query that says where UUID equals C31B or UUID equals 2A7EF, da 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 da. So we've got that query. We're going to give it the SQL string, we're going to give it the connection object, and we're going to give it the parameters, which will be bound in, and that'll just be UUIDs. Yes, okay. So let's run that, and then take a look at that data frame we get out. And you can see we do get the time, value, and UUID columns in its head, so it's just the first few rows. One thing I like to check is sometimes there's not data for all of the UUIDs. So if we do dot unique, okay, so we do have 2 UUIDs in this, good to verify. However, that structure with 3 columns isn't super flexible. What I actually want to do is separate out those the data for each of my data sources into its own column. So I'm going to do that with a quick pivot. And you specify which column which column you want, which column's values you want to be the new columns, which is UUID. The values are going to be value, and then index is time. And now values. If we rerun that and take a look at the data frame, you can see we do get 2 columns and those data sources. One thing you might find helpful, especially if your sensors like these don't necessarily have the same timestamps, is just to do a really quick resampling. For this data set, 15 minutes is good. I'll take a 15-minute mean, and that will make sure that it'll reduce nulls, it will smooth over maybe some of the noisy data, and that looks a little bit nicer. Don't you agree? Okay, so let's put that inside a method. UUIDs, let's just call it get data. We'll give it the UUIDs. Return df. All right, I'm going to put this up here. And there we go. So now that I've got, bringing this all together, I've got this query that returns 2 UUIDs in those columns. So I can say for row in MD, well, for each row we've got the HU, SP, SAT, UUID, SP, UUID. Actually, before we do that, let's have a get data return, take one more argument, which is names. And we'll just make sure that those names are, assign those names to be the columns so that we don't have to remember what the UUIDs are. We can just work with the names that we give it. So here I'm going to iterate through each of my error handling units and its data one at a time. My data is going to be the get data SAT UUID SP UUID. Names, I'm going to give it SAT and SP. and then print out the first 5 rows of each of those data. So we're just going to loop through each of those. For that error handling unit, we get SAT and SP. So it's a little bit more nicely named. Then for the next one, it'll proceed, over and over. And I think there's a good deal of data in here, so I'm not going to let it run for all of those. But what I can do, we'll just use the first one here. There we go. And now, because I put this matplotlib inline up there, I should be able to plot this. Let's do a quick plot and just see what we get. There might be too much data in here. We'll probably have to filter the data down. So you can see in this data set here, is we've got the two streams. There's a little bit of noisy data here, but it looks like that range from 2012 to 2013 might be a little bit clean. So we can just index into that. I'm going to make this a little bit bigger too. There we go. And if we wanted to just take a look at, let's say, June to July, because it had the most variation. And there we go. Oh, sorry, I still want just 2012. Go. So that is very interesting. It looks like the set point is maybe all over the place, and the supply air temperature sensor is static. So there might be some noise in this data. I think I might have the columns backward. But at the very least, now you have an idea of how to write a simple Python query, write some simple Python code to use a Sparkle query here to fetch UUIDs out of your Brook model, hand those to a time series database to get your data out, and then plot that and pull that into your analytics pipeline. I hope you enjoyed. Make sure that you check the link in the description for the contents of this code, and maybe a little bit more of a spruced up notebook and some examples of some basic analytics. Thanks.